In the beginning, there was silence. Not the quiet of an empty room, but a deep cosmic silence from a time before sound was even possible. In the first instant of creation, an instant so brief our words can't describe it, everything burst into existence. Time, matter, energy, space, all born in a single flash. But our story isn't about that flash. It's about something much smaller, something forgotten, unnoticed, drifting for billions of years. A single ancient particle, created in the very first second of the universe. Scientists call particles like it neutrinos, tiny ghosts of matter that pass through planets, stars, and even your own body without leaving a trace. But this story follows just one of them, a particle that witnessed all of cosmic history. It carries no message, but it carries a timeline, an unbroken path from the beginning of the universe until now. This is the story of that thread, a silent witness to everything. Our ancient particle is born inside a storm of unimaginable heat more than 1 trillion degrees. Space itself is a thick, violent soup of newborn matter colliding and exploding. But neutrinos are different. They barely interact with anything. So when the universe is only 1 second old, our neutrino breaks free. Free to drift. Free to travel through the cosmos for eternity, leaving the chaos behind. 3 minutes after the beginning, the universe cools enough for the first atomic nuclei to form. But light is still trapped in a glowing fog of plasma. Our neutrino, however, is unstoppable. It drifts effortlessly through matter so dense that even light is a prisoner. It sees the darkness before light even exists. Then, 380,000 years later, something incredible happens. The fog clears. The universe becomes transparent. For the first time, light is free. This is the cosmic microwave background, the faint afterglow of creation that scientists detect today. It's the baby picture of our universe. Our neutrino is there to witness it, not with eyes, but by simply being present as the cosmos changes shape around it, and it keeps moving. Hundreds of millions of years pass. Gas clouds collapse under gravity, sculpting the first stars and galaxies. Our neutrino glides silently through it all. It passes newborn stars burning brilliant blue, only to die in explosive supernovas. It slips right through collapsing black holes, moving too fast and interacting too little to ever be captured. It sees the universe evolve from simple to complex, from uniform to structured. Billions of years later, a new spiral galaxy takes shape. One day, it will be called the Milky Way. Our neutrino drifts through its young arms long before Earth is born, long before our sun even ignites. It passes the future location of our solar system. At this point, just an empty, dark cloud of gas, waiting. Then, 4.6 billion years ago, that cloud collapses. Nuclear fusion ignites. The sun is born. As light bursts outward, our neutrino passes nearby, completely untouched by the heat and energy. Around the young sun, leftover dust begins to clump together, forming the planets. One of them is a small rocky world wrapped in magma. One day, it will be our blue home, Earth. Our neutrino passes through it without slowing down. Millions, billions of times, as life on Earth quietly awakens and evolves from simple cells to complex creatures, to us. Right now, trillions of neutrinos are passing through your body. But only one of them, our neutrino, began this journey at the birth of the universe. Humanity begins to look up at the sky, first with stories, then with curiosity, and finally with science. We map the stars, predict the planet's motion, and eventually bend space itself with our theories. And all the while, our neutrino keeps drifting through our mountains, our oceans, and through the very bodies of the scientists trying to understand it. Then, one day, we build a new detector, one buried deep underground in the quietest place on Earth, shielded from all noise. It's a chamber the size of a cathedral, filled with ultra-pure water and lined with 1,000 electronic eyes, waiting in total darkness. All of it built for one purpose: to hear the universe's oldest whispers. And then, it happens. A tiny flash of light, a spark so small it should be impossible to notice. But this spark is different. It's our ancient neutrino, the same particle that left the Big Bang in its first second, the traveler that drifted through galaxies for 13.8 billion years. For the first time, humanity hears it. A single microscopic trace of the early universe. The detector logs the event. And for a moment, nobody knows it yet, but we have just captured the oldest thing humanity has ever measured. The universe's first witness has finally spoken. For days, no one notices. The signal is just one tiny point in a sea of data, buried in background radiation and equipment noise. But then, a young researcher spots something strange. A pattern. An energy level so impossibly low, it doesn't match anything from stars or supernovas. It can only match one thing: a neutrino from the first second of the universe. A relic from the creation of space-time itself. The team gathers. They run simulations, they check for errors, but nothing explains the signal. The data is solid, unavoidable. The world reacts with disbelief. How could anything survive that long? But it did. The universe had finally revealed a piece of its origin story. To understand what they found, scientists traced the neutrino's journey backward through time. Through galaxies, through the birth of light, all the way back to the beginning. They realized something astonishing. This neutrino had traveled in a nearly perfect straight line since the Big Bang. Not even the gravity of entire galaxies could significantly bend its path. And that means the direction it came from points to a specific location in the sky. A perfectly preserved coordinate of the universe's beginning. That spot in the sky appears completely empty. Just cold darkness. But when they looked closer, with more powerful instruments, they found a faint distortion in the afterglow of the Big Bang. A clue. The neutrino was born in one of the very first seeds of cosmic structure. But then, a new mystery. The neutrino's energy was slightly too high. It should only lose energy over time, but this one didn't. Either we misunderstand the early universe, or something influenced the neutrino on its journey. Something that doesn't emit light, something invisible. Months later, they found it. A tiny shift in the neutrino's arrival time, suggesting it passed close to an incredibly massive object. But there's no black hole or galaxy in that part of the sky. There's only one explanation: a huge invisible structure made entirely of dark matter. The neutrino, by pure accident, had just marked its location on our cosmic map. And here is the most incredible part. When scientists looked back at old data from detectors around the world, they found more of these signals. Dozens of them, all dismissed as noise for decades. Together, they weren't random. They formed a pattern, a vast, invisible web stretching across billions of light years. A cosmic highway that existed before the first galaxies ever formed. The neutrinos have been tracing this map for 13.8 billion years. Each one a breadcrumb from the moment of creation. We were never meant to find this map, but the universe left it for us anyway. A silent trail, leading us through the dark, telling a story that began with the light. We just finally learned how to listen. Thanks for watching. If you're fascinated by the secrets of the cosmos, be sure to subscribe for more journeys into the unknown.